All right, take it away, Richard.
Hi all, and welcome to GraphQL Hangout number 48. Today we've got a special guest speaker with us to talk all things GraphQL security. So thank you for joining. Quick round of intros before we get started, and then I'll hand over to Budha and our guest. So I'm Richard, I'm the lead user researcher here at Tyke, obviously helping facilitate these sessions to learn more about GraphQL API management from the wider community. So always keen to hear whenever anybody raises a question, a little bit around their background and why it is you've joined us today and what it is you're trying to find out more about. Obviously, that will all be around the topic of GraphQL security. So I'll hand over to Budha and Tristan, who facilitate the discussion. And yeah, over to you guys, take it from there.
Thank you so much, Richard. Hello and welcome, everyone. This is Budha. I am the product evangelist here at Tyke, and I love to talk all things APIs and GraphQL. So in today's session, we're going to be talking about GraphQL security lessons from the trenches. And like Richard mentioned, this is going to be our 48th session, and we've had discussions across a whole range of different topics. Security has been a very recurring topic that's come up quite frequently. So we thought we'll go a little bit more in depth this time with some of the key findings that Tristan and his team at Escape have done in this particular space. So hopefully we'll have a really, really great discussion. We've got a presentation lined up for you to kick things off. We will then go into a discussion in terms of questions and, frequently asked problems and challenges that people have faced in this particular world. At any point of time, if you do wish to ask us any questions, do feel free to do that in the chat or the Q&A section that you've got at the bottom. We will pick that up as we go into our discussion. Once the presentation is over, we'll also have you guys we'll provide you with the opportunity to actually ask the questions in person as well, if you so desire. So with that all in place, let us kick things off. Hello and welcome, Tristan. Thank you so much for joining us at the GraphQL Hangout.
Thanks, Budha, a lot for inviting me here today. I'm glad to be here and to have the ability to speak. Shall we start with the presentation? Let's go. Cool. So you should be able to see my screen now. Okay, very cool. So hello, everyone. Let's get to know each other a bit more. I'm Tristan. I'm the co-founder of the GraphQL security company, Escape. We're dedicated to helping people securing their GraphQL endpoints and improving security in the ecosystem. I'm French. I'm calling you from Paris right now, but I've lived in Argentina, in the US, and in Spain as well. I'm an engineer and an MBA, and I've worked in machine learning applied to source code analysis, more especially abstract syntax-tree analysis. So you see GraphQL, everything makes sense. And I also love security, so I started a GraphQL security company. So Escape, we created the first automated GraphQL security testing tool, and we have an in-house research team on the topic that spends full time auditing GraphQL APIs and improving the security of the ecosystem. So today we are going to talk about security lessons from the trenches to the Tyke's GraphQL Hangout. And I will start to kick off this presentation, like this discussion, by a quick introduction to GraphQL for those who are not familiar with it, and then present the security challenges of this exciting technology, and then present a bit the security best practices we got out of auditing a lot of GraphQL-based APIs. So GraphQL is a query language for APIs that embrace modern data's graph nature. So basically, you have a schema that will define all the data contained in your API, and then your front-end developer or the people consuming that API can write queries specifying exactly what data they want, and the API will send exactly that data back to the people that use the API. So it's very, very powerful and very flexible technology. It's based on a schema that contains the relations between the different data in your API. So it's a graph, and that's where the names GraphQL come from. So this is a very simple schema, but they can get pretty big when you're working with enterprises. So schema can get very complex. And then you can write a query. So here in this example, we are asking for a hero with his name and his height. and we have exactly that data back to the client. So that's how we use GraphQL. This is a very simple query, but we'll see very more complex queries during this talk. So what are the security challenges of this technology? So the first is that this is a pretty recent technology. It comes out in 2015, created by Facebook. And there is a lack of good resources about GraphQL security. We have an attempt to solve this on our blog. We publish regularly articles about that. But in general, there are no books, there are no courses, there are not a lot of tutorials about, in general, what are the best practices on securing GraphQL. And also, GraphQL is a graph and it's a language, so there is a wider attack surface in GraphQL than in REST endpoint. So let me explain a bit more why. So in REST security, you have endpoints with parameters. So you have some endpoints. These endpoints, you can send parameters to it, and you will get back precise data that you expect. Every resource has its endpoint, so access control is easy. Either you allow this endpoint to this user, or you don't allow this endpoint to this user. It's like very linear. In GraphQL, however, you have a full-featured language, so you can, like, every user can build complex queries, like that contains a lot of different identifiers that can query a lot of data in different manners. So there are way more possibilities to exploit and to create malicious requests to GraphQL endpoints and REST endpoints. And even worse, GraphQL is a graph. So if you want to secure critical or sensitive data in your graph, you have to secure all the path that leads to this sensitive data. So for instance, here, if there is a Stripe token here, I must ensure that my user cannot access it from this path, but also from this one and from this one. So that makes it a harder challenge to secure and to implement access control in GraphQL than in REST endpoints. Yeah, so we have to secure all the path leading to the resource. So now let's talk a bit about the security best practices of GraphQL, and especially the security best practices we got out of auditing more than 1,000 GraphQL APIs with a free tool that we built, GraphQL.Security. So GraphQL.Security is a simple website. You can go on it and enter your GraphQL API, your GraphQL endpoint, and clean and scan, and it will just give you the result, the security, some security insights about your endpoint. So on those 1,000 endpoints, we found about 6,000 vulnerabilities or security misconfigurations. That's a lot. What were those endpoints vulnerable to? Well, about 95% have HTTP misconfigurations or cross-site request forgery, potentially. 80% could have denial of service or complexity-based attacks. And about 20% disclose too much information to people. So let's solve that. So start with the basics: HTTP liar and cross-site request forgery. This is very simple. Probably most of you already know about that, but it's still often forgotten a lot. So there are a few security headers like strict transport security to avoid request hijacking. We need to enforce the right content type. So it's mostly content type application JSON, because you do not use multi-part or URL encoded with GraphQL. And if your endpoint is not a public endpoint, be sure that you set access control allow origin to your client's website, so malicious people cannot interact with your API. And there is something specific with GraphQL, is that you edit data or you post data with mutations. And sometimes people allow sending mutations through GET request. So they allow editing the data on the server through GET request. This is not compatible with the HTTP standard, so this should not be allowed. And combined with cookie authentication, it creates a critical cross-site request forgery immediately. And we have seen this very often, and this should be avoided at all costs. So now that we've seen the HTTP liar, let's go deeper into the graph and avoid abusive queries. So a GraphQL request or GraphQL document, this is the same, contains a lot of things, actually. So it contains operations, fields, directives, parameters, aliases, batches, and fragments. So those are all the features of the language. And basically, limits can be set for everything. That's how you secure a GraphQL endpoint. You have to control everything that your user can do with the language. So batching and aliasing are a feature of GraphQL that allows you to send several requests, GraphQL requests, in one single HTTP call. But what is something that can happen if you do that? Well, actually, if you do that, people can manage to bypass the rate limiting, because if the rate limiting is on the HTTP level, people can send one HTTP request, but that contains 100 GraphQL requests using batching or aliasing. And if you have a login in GraphQL, people can start to brute force the passwords using that technique. So batching and aliasing must be limited in GraphQL. Also, you can limit query depth. Like depth in the query is how deep in the graph you go using that query to query data. And if you do not limit the depth in the graph, well, people can create very, very deep query that will take a lot of time to be resolved by the server, that will create high computational costs for your infrastructure. More than depth, like query can become very complex. Like here, this is an example of a GraphQL query that is huge. And if you do not limit the size of the queries, you can end up with enormous requests that gets enormous responses and that can create denial of service. And about 80% of endpoints are still vulnerable to that. So that's a huge problem, and it should be limited. And the last part is avoiding information disclosure. So GraphQL is often sending a lot of information back inside of like to the user, and especially, for instance, in this case, it sends a stack trace of the libraries and the code that is used, and we can see that there is the library gateway with a version number, and that this library has a vulnerability. So if you let do stack traces, you tell hackers your libraries you're using, and eventually you show that you're vulnerable to some attacks. And finally, GraphQL is introspectable. That means you can have information about the schema of the API just by interacting with it. Sometimes people deactivate introspection, but in fact, there is like a feature called field suggestion, meaning when there is a typo, it sends you back, did you mean with something? And the thing is, if you have that activated, people can build back the full schema of your API by using open source tool. Like there is an open source tool called Clairvoyance. So those are schema we built back only by fuzzing, like sending a lot of words to an endpoint and registering like, did you mean this word? So we built back the schema. And in this specific case, they had an update admin feature, which was not protected because it was supposed to be hidden, and we are able to find it and to change the admin password of this company. So this must not be overlooked. So if we recap the best practices, we start with the basics with the HTTP layer and CSRF. We set the right headers. We never allow mutations with GET request. We put limits to queries, so batching, depth, complexity, and then we avoid information disclosure through disabling stack traces or debug mode in production. And if introspection is deactivated, we also deactivate the field suggestion because it allows to get too much information on your API. Okay, so that's for the quick kickoff. And now I'm excited to start discussing and digging a bit deeper inside of the security of GraphQL.
Fantastic. Thank you so much, Tristan. That was a fantastic presentation, just looking at some of the key issues. And I think, once again, I think we've discussed some of these things previously as well. And it's really good to almost get validated in the fact that, you know, after looking at so many different API endpoints, GraphQL endpoints, I think it's a fairly common problem that people are trying to solve when it comes to GraphQL APIs. So with that, I think let's kick things off. Obviously, people, everyone now from here on in will have the opportunity to speak. They have the opportunity to talk and ask us questions directly, or you can do so in the Q&A segment. I obviously have a few questions of my own, so I'm going to kick things off with those. You already touched upon one of them, which was around introspection. I think it's another common question that keeps coming up quite frequently. How do you deal with introspection queries within GraphQL, where it's enabled by default? So what is the best practice there? Do you let it stay open for public APIs? Do you disable it as a basic rule of thumb when it goes to production? How do you actually go about handling introspection queries for any GraphQL API, private or public?
Yeah, so that's a very good question. And so first thing is introspection is enabled by default in all major GraphQL engines. And actually, with a lot of engines, when you deactivate introspection, you still have the field suggestion that is enabled, and there is no way to deactivate the field suggestion. So basically, for a long time, it was absolutely impossible to completely deactivate introspection. So now, from a security point of view, securing through deactivating introspection is security by obscurity. And this is not a good practice by itself. I would say that introspection is not a security vulnerability, so you can keep it open, but you must ensure that nobody can, do malicious actions using your API. And you must ensure that access control is well implemented for all your API, all the queries, all the mutations, everything. So I would say introspection is not a security feature. You can keep it open. And only in some specific case where it's absolutely not needed, you can deactivate it because it's not useful.
Which obviously brings us to the next point that you just touched upon, which is around, access control. And we get this question as well quite frequently when we talk about authentication, authorization, access control. A lot of people tend to bring the lessons they've learned with, say, REST APIs and try to reapply that on, say, GraphQL APIs, which may work to a point, but as you have mentioned already, GraphQL works quite differently. The graph itself is structured quite differently. There's a degree of flexibility that comes with it. There is a degree of almost unpredictability in terms of the kind of queries that might be created out of it. Absolutely. So under those circumstances, how do you reconcile the world of, say, authentication, authorization, access control to something like field-based permissions and things on those lines? So what's again, the best practice around that? How should people tackle something like this?
Yeah, so you are perfectly right. And access control in GraphQL is very different from REST because in REST you have endpoints and you can put access control on the endpoint level. But in GraphQL, you don't have endpoints. You have like objects that are connected together through a graph, and you have fields. And the best way to implement access control in GraphQL is field-based access control. So every single data point, every single field of data in your endpoint must have access control implemented for it to ensure that nobody can that should not have access to this field, to this data, can access it. If you implement access control on a query based, you cannot be sure, and you will never be sure that you didn't forget something.
That's true. Absolutely. And I think that's kind of the philosophy that we've taken as well here at Tyke. And I think when we were looking at, GraphQL adoption ourselves, one of the issues that was coming up again was really security. How do we make sure that GraphQL is secure? There's a whole lot of questions around that. And we sort of put a couple of those things together with query depth limiting, starting off with that, with field-based permissions in there. My curiosity again extends beyond just querying, of course, because with GraphQL, it's not just about queries. You also have mutations, you even have subscriptions. So how do you then extend authorization into those areas as well, where how do you, is it to do with updating a specific field and you're restricting access to, who can or cannot make those updates to those particular fields? When it comes to subscriptions, what are you kind of restricting there? People who can in real time listen to updates that are happening. So how do you reconcile some of those authorization field-based mechanisms to, say, the other aspects of GraphQL with mutations and subscriptions?
Yeah. So actually, for mutations, it's more like REST endpoints, because for mutations, generally what you do is you use a GraphQL feature, which is called input objects, or even just parameters. And those parameters are related to the mutation itself in most cases. So for mutation, it's more like REST. Subscriptions are a bit specific, and there is a debate in the GraphQL ecosystem about subscription right now, about how that must be implemented in production, what are the good practices. I would say subscription should share the same access control as queries and as the graph in general. So basically, I would separate access control for querying data, which is related to the graph itself, to fields, and access control for mutations, which is more a bit REST-like. And what's interesting with that is, for instance, companies like Hasura, they decided to do to send data through REST and to query data through GraphQL. So you see, sending data mutations, it's a bit more like REST. And what's very specific about GraphQL is the query system, and this is where access control has to be focused.
Okay, I see we've got a hand raised here. Doc Jones with us. Do you have a question for us? Feel free to unmute yourself and ask us.
Yes, Budha, thanks. Actually, I have two questions. The first question is on rate limiting. Isn't the like best practice to use query cost analysis instead of trying to do rate limiting through HTTP? And then my second question is, oh boy, I think I might have forgotten my second question.
No worries. Let's start off with the first one. I think if you get to the second one, we can pick that up as well. So go ahead, Tristan. Rate limiting, cost query analysis.
Yeah, you're absolutely right. And this is something very difficult with GraphQL, because rate limiting in GraphQL is not about the amount of requests that you send, but about the complexity of the request that you send. So in GraphQL, putting a rate limit on HTTP does not make a lot of sense. And it should always be preferred to have complexity analysis. It's very easy to implement over complex complexity analysis and to block legitimate users. So that also needs to be taken carefully. We are working. I'm not an expert of Tyke's platform. I think they have like a way of implementing rate limits. We are also working on an open source package for GraphQL for JS, JavaScript or TypeScript-based GraphQL endpoints that implements a good rate limit system for GraphQL out of the box.
Great. Does that sort of answer the question there, Doc? Because you're absolutely right. I think when it comes to rate limiting, it's a little bit different, but I would almost put it as one of those, areas of defense that you sort of have in the beginning, and then obviously you can get more complex with it. It's a starting point, and then you move into more complex areas of GraphQL security, perhaps.
Yeah, that does answer the question, and the second question reoccurred to me gratefully.
Thanks.
So what is the best practice for doing tracing in GraphQL, and even more specifically in a federation implementation?
Yeah. Well, tracing is it's a very complex problem in GraphQL, and especially in a federation context. I think we've built we have an article, a blog article about that. But mostly the tracing, we should be at the resolver level, and it should be the information about the trace should be transmitted from resolver to resolver. I don't know any standard about that, unfortunately. I think this is still artisanal, and nobody has the right solution right now. So yeah, it's an interesting question to explore.
I would like the link to your blog article. I would like to read about it, because I think as far as observability is concerned, tracing is the best option for GraphQL. So understanding the query, there's a great paper at the ACM about doing query cost analysis, and they did some tests around not only the cost of the query, but also the cost of the resolver and delivering much more accurate results, which I found that to be true.
Yeah.
So it's kind of like a 2-level cost analysis to get something that's accurate for GraphQL.
I think another place where I think we ourselves are looking at, because this is a question that's come up quite a bit when we are dealing with different data sources, for instance, combining them into a single data graph, or again in a federated environment, trying to figure out where the queries are coming from, what kind of resolvers are going into, what kind of subgraphs are going to be responsible for handling the queries that are coming in. So we have started looking into this already through Open Telemetry as one of these areas. Thank you so much, Ahmed, as well, in the comments for pointing that out. And I think Open Telemetry and distributed tracing potentially could be a solution here. And I think that's something that we ourselves are exploring. Perhaps people in the audience with a bit more experience around this space might be able to tell us a little bit about what they have found out in this area. But yeah, this is something that we are looking at. It is a problem in this particular space. It's something that we ourselves are looking at as well, beyond our security aspects of field-based permissions that we talk about, the query depth limiting that we've talked about, and just looking at and analyzing what's really coming in the request to the response, what that journey really looks like, and if things are going wrong, where are they going wrong, and kind of tagging things there a little bit more. So yeah, Open Telemetry potentially a solution.
That causes me to have 2 more questions, especially around the
Sure.
Open Telemetry thing. One, is that something that's being implemented at the DevOps level instead of the GraphQL team level? And 2, I would love for you to come back and talk about your experience once you guys have Open Telemetry implemented. Would that be possible?
Oh yeah, absolutely. we are very keen on sharing the information around Open Telemetry and our lessons around this as well. Within our team, Sonia, our senior product manager, really leading this charge at the moment. But you're absolutely right. I think there are different levels at which you could implement Open Telemetry. And I think we are, again, looking at that extension of where it makes the most sense, what kind of information, tracking what kind of information makes the most amount of sense when it comes to the context of GraphQL as well. So that's all work in progress, and we'll love to come back in the future and share our findings, hopefully in a way that benefits everyone who's been looking at the same problem as well in this particular space. But thank you so much for the question.
That would be fantastic. I just want to say thank you both for doing this session, and thanks for taking my questions.
Thanks so much for asking them. Thank you. Okay, moving on to the next one, we've got another question that's come in where Paulo, if you want to unmute yourself, you feel free to do that as well. But I'm happy to read out your question as well.
Okay,
there you go.
Hello everyone. I'm Paulo
Hello.
Renato. I work as a developer advocate for mobile API security. So my question is basically, I see that everyone concentrates security about rate limiting, and then they provide the rate limit headers in the response, what makes the life of an attacker very easy to go around your rate limits. And then I also don't see people talking about separating who is in the request from what is doing the request. So who is in the request is the user that you will be authorized and you authenticate, and then you authorize access to the resources. What is the part that is doing the request? So is your genuine mobile app, your genuine web app? Is someone doing a call request or a postman request or a bot? And your backend needs to have a very high degree of confidence in what is doing the request. Otherwise, your API defenses are very vulnerable to be exploited. So in GraphQL, that is more difficult to secure than API, as already told. So our guest has any comment on regarding who versus what is doing the request, is tackling that?
Yeah, thanks for your question. So to be clear, you're speaking about the user agent headers?
For about what?
About the user agent?
User agent is very easy to spoof.
Yeah, exactly. So it really depends on if it's a public or a private GraphQL API. If it's a private GraphQL API, of course, you should implement like a certificate, like a verification of a certificate for accepting requests. And we have seen that a lot among production endpoints. So for instance, even for instance, banking applications, so they had a private API, and that should have been used only by their servers, but they still opened it to the internet, and they didn't verify who was sending the request, and that led to a critical vulnerability.
Can you elaborate what is a private API?
Yeah, exactly. Oh, a private API. Okay, so it's when I'm speaking about a private API, it's an API that should be used only by the company itself. So it's not internal because it can be open to the internet, but it should be used only by the company's mobile app or the company's website. It's not designed for external developers to be used.
I don't like the term private APIs because they don't exist. From the moment that you have an API and is not in the internet, is a public API. Okay, yeah. Because I can reverse engineer your mobile app or web app, despite your API being should be only used by your mobile app for your app. In fact, it's public from the moment you release it as a web app or a mobile app. Any API is a public API. You may not have documentation for it. You may not be able to find the DNS for it by querying and fusing your server, but it's public because you just need to reverse engineer the web app or the mobile app, then build them with the man-in-the-middle attack. You can easily construct all the API endpoints.
Absolutely, you're right. You're perfectly right, and very often those kind of APIs that are not designed to be public, but still are open to the internet, are less protected than the ones that are designed to be public, and they are often overlooked by the developers or by the security teams because they are believed to be harder to find. But
yes,
not.
Exactly. As I see that a lot in my work, daily work. People just think because the API is not published, they think they are okay. But with the open source tools that exist nowadays, it's very easy to find them and build the schema of them, like you do with GraphQL with Clarivoyance, the tool that you pointed. Also exists same tools for REST APIs and GraphQL's APIs. So you said checking the certificate. So I think you are talking about certificate pinning implementations, correct?
Yes.
Okay. Cool.
I think in terms of just the internal versus external APIs, or I think what private versus public, I think there's obviously the definition of easy or difficult to discover, but I think there's another aspect here where historically a lot of the private APIs or the internal APIs were, again, not open to the web at all. It was essentially just within the secured network of an organization. Once again, maybe there's a work around that, but typically that's kind of where those APIs were. It's within that network, probably a little bit more trusted within those system. Although we are moving into a world of a zero trust security mechanism where you don't trust anything by definition. Everything has to sort of prove their worth, be worthy enough to be part of that of the system. So. So I think historically that's what internal APIs were meant to be, or private APIs within your network. You're essentially supposedly secure, but of course that's as you pointed out, that's not always the case. You need to have the right authorization, authentication mechanisms in place to be able to ensure that any system or any application or any API that is being requested from or called is secure. And that's kind of where the debate keeps going on in terms of, okay, what are the right tools to be able to do that? What are the right practices to be able to handle some of these things? And Doc mentioned something interesting in the chat as well, where she mentions Twitter has a private API model for GraphQL, but their public API at Twitter is REST. and is a client for the GraphQL gateway. So different implementations potentially are different areas that I think everybody's trying to solve the similar security issues, but like Tristan, you mentioned earlier on, it still feels like it's early days into the world of GraphQL security, where I think we're still looking for the best practices being a bit more well-defined versus people trying to implement and finding solutions out there for their own selves. Yeah, and that has led to. I'm jumping on that because I believe it's an important thing with GraphQL. GraphQL is often used as a layer on top of a REST endpoint or REST API, and often when people are doing that, they believe that the GraphQL endpoint must be secured, but the REST endpoint behind it is often overlooked as well in terms of security. And this is something that happened to us in a real life scenario. Basically, it was, again, another banking app, and they had like a GraphQL endpoint on top of a REST endpoint. So basically, the user was sending GraphQL, like the mobile app was sending GraphQL request. The GraphQL server was then translating that into REST request to another endpoint behind it. And the GraphQL endpoint, the GraphQL server, had one token. It was a Google Cloud token. One single token for communicating with the REST API. So this was like a very powerful token, not related to the user of the mobile app. Well, by sending a specially crafted GraphQL query, we were able to create an error and an unhandled exception inside of the GraphQL API, and it had debug mode activated in production. And so it sent back a trace back to us that contained the token. It's like the GraphQL endpoint was saying, okay, I tried to reach the REST endpoint with that request, that Google Cloud token, and it didn't work. And the worst part was that the REST API behind it should not have been open to the public network. It should not have been open to internet. It should have been kept inside of the company's infrastructure. Yet they forgot to do that. So the REST endpoint was accessible by anybody.
Yeah, that is a very common mistake that happens.
So I think question to you, Paolo, in terms of your line of work so far, are there particular security practices that you are following at the moment, which perhaps helps out in your day-to-day work when it comes to GraphQL APIs? Are there anything that you have implemented on your end?
To be honest, I've not worked too much with GraphQL APIs until now. So basically, I was curious because I'm doing in this moment at work an integration for TIC API gateway for our solution. And I saw this meetup, and GraphQL is a thing that is. So basically, in my line of work, we protect GraphQL and REST API, but not directly doing something with the REST API or with the GraphQL API. So we are agnostic of what type of API you are using. So I cannot give you specific recommendations for GraphQL or for REST API, because if I go further, I will doing a pitch for my product I'm working in, okay? Because we are really agnostic of how do you query the backend to protect, to give the high confidence to the backend that is talking with what it expects. So my question was, because we're always curious, if anyone else there in security is tackling the problem of what is making the request, because for what we understand, our company has a unique position in the market. In that regard, nobody else is doing what we are doing. And I'm always curious to find anybody else that is in the same line of approach.
I'm quite curious in this particular scenario where, when we think about who is making the request or what is making the request in this case, I think a lot of time that question stems from authentication practices typically, and usually I tend to look into the world of OAuth or OIDC potentially working together and solving some of these challenges. So in your opinion, in terms of what you have looked at, and again, talking about agnosticism, I think the similar case with us as well with our API gateway that we've got right now. We work with GraphQL, REST, gRPC, any of those different APIs, and we kind of see similar challenges across the board. And I think that's where we are looking at support for some of these different security protocols, security practices, and methodologies out there. So curious to know from you as well, and in terms of OAuth 2.0, 2.1 plus OIDC, that combination, does that potentially work for you? Are you seeing limitations to that in what you're doing?
That part only identifies who is in the request, not what is doing the request, okay? Is a common misconception in our industry to tie up authorization, authentication, identifying what is doing the request based on the user. Okay, people, I was also thinking like that when I was working for a mobile app company, a big one in the UK. Before I became a developer advocate, I was also in that line of thought. So I think OAuth and all wish and bells of user authentication will be enough, but it's not. This only proves who is doing the request, the user in the request, not what is making. Is it a genuine instance of your mobile app? Is it genuine instance of a web app, or is someone using Postman or just pull requests or a bot? An attacker can steal the token from a user authentication and then use it to make requests to the API backend, no matter if it's GraphQL, it's REST API. And the user authentication will not help the backend to have a very high degree of confidence that what is making the request is a genuine instance of their clients. So the clients will be normally mobile apps or web apps. So you need to have another thing doing that task for you. For example, in the TKPI gateway, our integration will work in the hook, not in the authentication hook, just to give you an idea. Because before you authenticate users, you need to trust that what is making the request is really a genuine instance of the client. So to get that genuine instance of the client to attest it, you need to search in Google for mobile app attestation. Okay, so currently it's achievable in mobile apps. In web apps, it's very hard because the way the web apps browsers work. So basically you hit F12 and you have access to everything. So your best choice in a web app to attest the integrity of a web app that is basically using fingerprint techniques. So you need to have something running or capture without human interaction. So is your best bet in web apps. In mobile apps, you have mobile app attestation. I think we were pioneers on that. And then Google and Apple start doing trials with our product. And later on, after they done some trials, we saw that they came with copycats almost, but they are not totally exactly doing what we do. So, but they do something similar. So basically is you have a SDK running in your mobile app that will attest the integrity of the devices running on. It will, but you'll not make decisions on the mobile app, because if you do decisions in the mobile app, the attacker can tamper with it. Decisions are made in a cloud service outside of the app. So is our mobile app attestation is done by us or by Google or by Apple. Is your best choice is to give the confidence to a backend that it knows what is doing the request. Mobile app attestation for browsers, you need to use captcha without human intervention or fingerprint techniques.
Got it. Okay, cool. Fascinating. Absolutely. I would love to go deeper into discussion. Perhaps we'll pick it up either on another session or probably offline as well, because
Okay.
I have definitely got a lot of questions around this. So thank you so much, Paul. This is quite a discussion. And I think this is a very valuable one as well. Like you said, there are a couple of misconceptions perhaps when it comes to some of the implementations that are out there, especially in some of the specific contexts that we see today. So would love to pick this up again in a future session or and offline as well. So thank you so much.
Yeah,
Paul.
feel free. I will be glad to speak and learn also, because we all learn with each other.
Likewise.
Yeah, 4 years ago, I was not aware of all this stuff. I was just a happy API backend developer, thinking that I know everything about security.
Right. Yeah, that's the beauty of security, isn't it? There is a significant humbling experience that comes with it, because no matter how much you know about it, the landscape keeps changing, and I think there are always going to be tools and new standards coming up that would either make life easier for us, or it's going to make life easier for the attackers sometimes. But we'll see how that all works out. I think it's going to be a learning experience for everyone. So thank you so much, Paul.
Yes, it's a mouse and cat game with the attackers all the way.
Absolutely. Thank you so much. All right. Not seeing any further question yet, but I do have a couple more. Tristan. So
sure.
There's obviously, we've spoken about introspection, we've spoken about error handling, we've spoken a few things about best practices as well. I'm quite curious in terms of your lessons from the trenches around the good, the bad, and the ugly of any kind of stories perhaps you might have come across of people really not understanding the situation or the scenario when it comes to GraphQL security or security in general, and have really gone wrong from where they would have wanted to be otherwise.
Yeah, absolutely. So I've already told a few stories about what we found in production, but I see three main reasons, three main situations where GraphQL APIs are at risk and which led to critical vulnerabilities in production APIs. So the first one is when people rely too much on disabling introspection for security. And this is what happened in the production. It was a food delivery company, and they built a full GraphQL API, and the GraphQL API was used by both their mobile app and their own admin panel for the user, like the employee of the company. And the admin panel queries and mutations and fields were hidden because introspection was disabled. But still, using the open source tool I mentioned in my talk, using the fact that the GraphQL endpoint was leaking information about the schema, we were able to build back the full schema of the GraphQL endpoint, including the admin-related stuff. And we discovered two interesting things. So the first one, they did not implement access control on the private comments of the support about their users. So we could build specific requests that fetched all the discussion of the support, internal discussions about their customers, like, okay, so this one didn't pay, just block him, or this one, he changed the account email, the new password is that. And so we had a lot of private data through that, because they believed just disabling introspection would make that nobody could find it. And the second thing is something I mentioned briefly. They had like an update admin mutation, so an update admin equivalent of a post request in a post endpoint in REST to change the admin password or admin properties. And again, this was not protected properly, so we were able to actually brute force it and change the admin password. So first thing, relying on introspection for security only is absolutely a bad practice. Second situation is when you generate GraphQL from a database schema. So this happens often. You have like a SQL database or any database, and you generate a GraphQL schema out of it. So we audited the company that was doing that, and our security tool at Escape, its goal is to explore the GraphQL endpoint as deep as possible to find everything that could have been missed. And we discovered that in their schema generation system, they forgot to disable the integration in the API of sensitive data, including passwords, hash passwords, including personal information of the people. So it was not mentioned in the introspection, but if you create the right field and the right objects, you could access the password of the people and the personal information of the people. So that's the second situation, generating schemas from databases and forgetting that some things that are in the database must not be accessible by the public. And the last situation is where, as I said, GraphQL is used as a proxy from a REST API, like on top of a REST API. And especially, there is a situation where you can manipulate the GraphQL API through server-side request forgeries, meaning you can manipulate the GraphQL API instead of fetching the data from the company's REST endpoint, fetching the data from a malicious REST endpoint instead. So, for instance, you can send a link to a user of the company or a customer of the company, and he clicks on it, and he got the impression that he's reaching the company's GraphQL API, and he is. But in fact, behind the trenches, it's like behind it, it's a malicious REST API, and we can manipulate the response and send anything that we want inside of it. So that's the first situation. Using GraphQL on top of a REST endpoint can lead to very bad security situations or security incidents if it's not handled properly.
Fair point, fair point. I think, Richard, you might have some thoughts around the second point that he brought up, which Tristan brought up, which was around automatic GraphQL schema generation. I think we've had this debate a few times where, there's always this debate of getting started and up and running quickly with GraphQL, for instance, and how do you get started with that really, really easily? And can you just, plug in a database and it'll just generate the schema for you? And hey, you've got your APIs already in place and you can start playing with it, versus actually taking the time of thinking, okay, what does being production ready with an API, specifically GraphQL, actually means? Do you actually want to be exposing that much information? What kind of information should people have access to? What kind of things should they be able to do? And what do you need to actually do to make that all possible? So curious, Richard, I'm pretty sure you've got thoughts around this as well on this one.
Well, yes, it's come up time and time again around like how if you're following a domain-driven best architecture, best practice, then potentially you shouldn't just be exposing your underlying architectures. There needs to be some schema design that happens. But yeah, we're currently having a lot of internal discussion around, okay, what comes first, the data sources, and then the schema, or the schema and then the data sources. I think there's a lot of design exploration that needs to be done around that. I think one of the things that's come up, unless there's any further questions, I can see some raised hands.
I see, Doc, you've got your hand raised there.
My favorite story about schema generation was from one of our customers who was new to GraphQL, and they thought, well, let's let the code generate the schema. And they were very excited about that possibility, until it came time to update the schema, and they learned that no one understood the schema. Nobody understood the schema because no one had ever worked with one before. So yeah, it's good to understand. It's good to design your schema and understand what it's doing.
You're absolutely right. I think there's always going to be that thing with tools where, you're trying to really simplify life in terms of how do you adopt technology, or how do you actually get to go to market as quickly as possible, or get to a POC as quickly as possible. But then there's always going to be that next step. Okay, do you actually understand what's really going on? Because ultimately, either you need to understand it or someone with your team needs to understand it, so that if there is ever a situation where you have to either debug something or maybe even extend the capabilities beyond what it's capable of doing at the moment, or even analyzing what's really going on in your system, I think there might be challenges associated with it. So there's always going to be, I think, that balance where how simple, how convenient do we want to make tools so that it's easy for people to adopt and get up and running with their own services really quickly. But at the same time, what kind of information and knowledge base do you actually need to be able to at least have a basic level of understanding of what the tools and the configs actually mean? So absolutely agree with you on that.
I think there is I can jump on this, and I think there is a philosophical question here about GraphQL, because the misconception about GraphQL is that since it's a query language, we can give any schema to the front-end developers or to the people that consume the API, and it will be fine. But in reality, a GraphQL schema, it's a user interface. It is a user interface, and people will consume it, people will use it for specific purposes. So it must be carefully designed for the end user of it, which would be front-end developers or any developer that consumes the API. Thinking other way leads to this kind of situation where the schema is absolutely unusable. And I believe like crafting the schema properly is a very, very good start for production GraphQL.
Absolutely. And I think we've seen I think the other point that you also brought about when you're talking about, building out GraphQL on top of REST endpoints, obviously it has its own benefits because you're really trying to combine data, removing data silos. Yep. But if you're just doing that as a standalone and really not thinking about, once again, what does a production ready consumable API need, or really what does that actually look like? It's not just about the design and the development of the APIs. It goes beyond that. That's like step 1 and 2 of, say, a 6-step process almost. You need to think about the security aspect of things. You need to think about, basically, you need to think about full lifecycle API management. And
Absolutely.
You need to think about the documentation. You need to think about how you would be handling perhaps versions at some point of time, where obviously GraphQL versioning is a concept of its own. And there's debates around how to handle it or whether to consider it at all. But there is a lot of different things that you need to think about when it comes to actually making production-ready APIs, and just dumping schemas perhaps is not going to be the answer, or dumping a database and pushing it to a GraphQL endpoint and generating that automatically perhaps won't be the best production-ready situation or scenario that you would want.
Absolutely, and that's exactly also the reason why we built Escape. When you have for instance, when you're using federation and you're federating different GraphQL APIs from different teams, how you have 200 developers working, or even 1,000 developers working, pushing commits every day or making merge requests every day? How do you know that at some point there is not one single developer somewhere that will make a mistake and that will disclose, make available to your GraphQL API your Stripe token? How do you know that? So that's why we build Escape, because when there is each time there is an update in the GraphQL schema, we will explore all the GraphQL API. We'll see if there is data leaks inside of it, and we'll alert the people, the relevant people, saying, hey, why is there a Stripe token available here in your schema very deep? Is that normal? And that's exactly why we started working on that.
And absolutely, I think that's kind of just to give a bit of a background why we really wanted to have Tristan on this hangout as well, because I think our team met you at the GraphQL London meetup, I think a couple of months ago.
Absolutely.
And it was really from a point of, okay, security is a concern from both of us, and what you were providing essentially was that analysis of, okay, where are those security vulnerabilities right now? When you're building your APIs, where are things going wrong? Where could things potentially go wrong? Yeah. And we saw that synergy here with us, where we're looking at that execution side of things. Okay, now that you've figured out that you've got vulnerable APIs, then how do you actually make sure that you've got the security practices or security methodologies supported and in place for your APIs? And that's kind of how we sort of wanted to get this partnership going with us together and having this discussion. I've got a couple of raised hands. We are almost at time, so I'm going to give Paulo, I think you've have your hand raised here for final comments.
Yes, just about the best security practice with GraphQL API, and I don't know if the Escape's solution is detecting that or not, is when using numeric IDs, for example, for the resources like a user, that makes normally applications vulnerable to Ebola. to escape detect that.
Yeah, absolutely. You are mentioning vulnerable direct object references.
Yes.
And absolutely, we know it's a huge problem, and we have like a specific security test that is absolutely dedicated to finding that kind of stuff. And it happened, I'm not saying the company's name, but it happened in very big companies, very big tech software companies. So everyone can be vulnerable to that. And basically it happens when you are referencing objects by numeric IDs like 1, 2, 3, 4. And so people can basically enumerate the data just by iterating over the integers. A public example of that is Facebook directly. At some point, Facebook had a problem because you could enumerate all the profiles just by iterating over the integers.
Yeah, you have Stack Overflow too.
Yeah.
That is the most common problem across all APIs. If you see the studies that came out, no matter if from my company where I work or other companies, Bula is always the main finding in any security analysis that people do to APIs. So you have Alice and Knight studies in the fintech world, in the banking was Bula, in healthcare was Bula, and even last week another study came out, was again Bula. So I think that is very important to be mentioned, no matter if you are using a GraphQL API or a REST API, please don't use numeric IDs. I know that is very easy to use because normally the backend frameworks give them by default for you for free. So you build a REST API endpoints or whatever out of the box with numeric IDs is how the backend frameworks normally work. But do your own effort and change them from numeric IDs to hashes so that people cannot enumerate anything.
And you're absolutely right with Bula as well. I think it's something that come up quite often. I think it's been part of the OAuth top 10 security vulnerabilities for a long time, I think, at the moment. So it's definitely one of the big concerns in this particular space for sure. So hopefully we'll be doing a session on the OAuth top 10 and what that means in the API and API management space soon. So perhaps you guys will be joining us for that as well. We are just over time by 3 minutes. Doc, I see your hand raised. Perhaps final comments from you as well.
Yeah, I just had a really quick question for Tristan. This is sort of forward-looking, so I don't think it'll take a long response, hopefully. So I just was curious if you had looked at the security implications of replacing WebSockets in subscriptions with RSocket. So RSocket doesn't operate at layer 7. It actually operates at layer 5 and 6, layer 5 or 6. And I was just curious if you had looked at that. I know it's been implemented in the spring version of GraphQL, but I don't think it's like widely adopted yet. I know that we're headed that way because there's a lot of Oracle and Twitter and GitHub, and a lot of the big players are looking at replacing WebSockets with RSocket.
No, like I perfectly understand your concern. We hasn't explored the security integration at this modification right now, but this is probably something we're going to do because we see more and more GraphQL endpoints coming from Spring, coming from Java, the Java environment, so this is definitely something we're going to explore.
Yeah, cool. It's similar. It's similar to what we are also thinking about as well, because when we've got a subscription implementation right now, when we are trying to secure it, we're again looking at WebSockets at the moment, but we know there are limitations there. And I think while it's doing the job at the moment, I think there's probably a future where things are going to be a little bit more efficient and better handled. And I think RSocket could be one of the ways to handle it. So absolutely would love to have a discussion on that too in the future session for sure. There is just so much to discuss. I think I'm always excited by this to the point where I think I get my geek mode on so many times. And I'm a big fan of horror movies. And interesting enough, last night I was watching one of them, which is a classic, which is the Blair Witch Project. I'm guessing some of you might have seen it or watched it. And really, when people are shouting out names in the dark and people, you don't know who's actually replying to you. And my brain was going, if they had the right authentication mechanism there, they might be able to find out if it's a witch or the right person. But that's my geek mind working on a horror movie. Regardless, thank you so much. This has been a fantastic conversation. Thank you for all the questions, Doc, Paulo, and thank you so much for the wonderful presentation, Tristan. Really great insight into the world of GraphQL security. I'm pretty sure there's a whole lot more to explore. There's a whole lot more to talk about and discuss in the future as well. So we would love to have you back as well, perhaps for our 50th anniversary, or maybe a future one next year as well. So thank you so much for joining, and thank you so much, Richard, for co-hosting the session with me.
Yeah, thanks a lot, Budha, for inviting me and Richard, and it was a really exciting talk. By the way, I'm currently exploring how to protect GraphQL endpoints using Tyke and Escape at the same time. So probably we'll see some content, exciting tutorials about that very soon.
Awesome. All right. Thank you so much, everyone, once again. And until next time, have a great day ahead and take care of yourself. See you next time. Bye-bye.
Bye-bye.
Bye-bye.